In this video, we are going to be learning about the discriminant. Okay, so say you've got a quadratic. We know that a quadratic can be written in the form ax squared plus bx plus c, and let's equate this to 0. For a quadratic in the form ax squared plus bx plus c, the discriminant is b squared minus 4ac. And the discriminant is used to determine the number of roots, the number of solutions that your quadratic will have. And apart from determining the number of roots, it also determines whether these roots are real or imaginary. You learn about imaginary roots, imaginary numbers. For now, just know that it's a thing. So say you've got a quadratic and you find that your discriminant b squared minus 4ac is, for example, less than 0. What this means is that there are no real solutions. It means that quadratic equation has no real solutions. We'll look at a few examples in a bit, but right now I just want to go through a bit of theory. I promise it's not a lot. And in fact, if we were to draw this on a Cartesian plane, what we're looking at is we've got our y-axis and we've got our x-axis. Let's just say we've got a quadratic, y equals x squared minus 4x plus 7, right? I want you to use the quadratic formula and try to solve this equation, equate it to 0 and try to solve it. So that will be x squared minus 4x plus 7 is 0, and so a is equal to, our coefficient of x squared is 1, coefficient of x is negative 4, and our constant is 7. Now I want you to go ahead and substitute this into the quadratic formula. So x is equal to, that's minus b, so that's going to be a positive 4, plus or minus the square root of 4 squared minus 4, a is 1 and c is 7, and all of this is being divided by 2 times a, so 2 times 1. I want you to punch all of this into the calculator, and notice that you're going to get a math error on your calculator. So in this case, what actually happens is that you're not going to get any real solutions, right? So no real solutions, or just simply no solutions for now, since we haven't started looking at the whole imaginary number stuff. So if we were to actually draw this graph on a Cartesian plane, in fact, what we can do is to complete the square. If we complete the square, that is x minus 4 over 2, so minus 2 squared. That's going to be minus 4 plus 7, which is plus 3. Okay, so our turning point for this graph is going to be 2, 3. Okay, so 2 in the x-axis would be somewhere here, and then 3. So this is that point. So our graph is going to look something like this. And when we were solving x squared minus 4x plus 7, we're essentially saying we've got two equations, y equals x squared minus 4x plus 7, and y is equal to 0. And we're solving these two equations simultaneously. So that would mean we equate this part to our 0 and then solve. But notice that y is equal to 0 is the same as our x-axis. That's the equation for our x-axis. So if we look at it graphically, if we're going to solve these two equations simultaneously, right, we're basically looking for points of intersection. So if you look at the graph, you can tell that our x-axis is not intersecting our y equals x squared minus 4x plus 7. So since there are no points of intersection here, we're not going to get any solutions. So hence, when you calculate using the quadratic formula, you're not going to get any real solutions, you're not going to get any solutions. So that's the graphical representation of when b squared minus 4ac is less than 0, you do not get any real solutions. And so here we could have actually substituted this into b squared minus 4ac just to check that it's in fact less than 0, b squared minus 4ac. So our b is negative 4 squared minus 4 times a, which is 1, times c, which is 7. 4 squared is 16, minus 4 times 7, that's 28. So 16 minus 28, that's going to be minus 12. Minus 12 is indeed less than 0, so b squared minus 4ac is less than 0. Hence, we get no real solutions from our quadratic equation. So now let's look at the scenario where our discriminant is greater than 0. So b squared minus 4ac is greater than 0. Here we get two real roots or two real solutions, two real roots. Sometimes this will be referred to as two distinct roots. Two distinct roots. That's the same thing. Alright, so what this one would mean is that when you solve your quadratic, you're going to get two solutions that are different from each other. So let's say we've got y is equal to x squared minus 5x plus 6. Alright, so let's sketch that on a graph. This is our y-axis, this is our x-axis. So let's say we wanted to solve, so let's say we were solving x squared minus 5x plus 6 is equal to what? Is equal to 0. And this we can factorize by side. That's going to be minus 2 minus 3. So you get that x is 2 and x is 3 and x is 2. Okay. So let's say our curve looks something like this. This here will be x is 2, this is x is 3. Ignore the scale for now, that's not the point. The idea here is that, like we said, when we have this equation here, it means that the two equations that we started off are y equals x squared minus 5x plus 6 and y is equal to whatever was on the right hand side, the 0. So we had these two equations, then we solved them simultaneously. So we equated those two equations together to then get x squared minus 5x plus 6 is 0. So whenever we're solving any two equations simultaneously, it means we are looking for points of intersection. So in this case, we're looking for a point of intersection between our curve and the x-axis, because the x-axis is the one that has the equation y equals 0. So as you notice here, we are getting 2 points of intersection, and these are what we then call our two distinct roots, our two real roots. And if you check your b squared minus 4ac, our a is equal to the coefficient of x squared, so that's 1, b is our negative 5, and c is 6. Let's substitute into b squared minus 4ac. That's going to be negative 5 squared minus 4 times a, which is 1, times c, which is 6. So 5 squared is 25, minus 4 times 6, that's 24, and you get 1. 1 is in fact greater than 0, so our b squared minus 4ac is in fact greater than 0, so hence two real roots. Okay, or two distinct roots. That's why we get two different roots. Now let's look at a scenario in which our b squared minus 4ac is equal to 0. So here you're going to get one real root. And sometimes you might see this being referred to as a repeated root. That's essentially the same thing. Okay, so let's look at a graphical representation of this. Say we've got y is equal to x squared minus 4x plus 4. Alright. This here is our x-axis. Our turning point, if we complete the square here, this is going to be x minus 2 squared minus 4 plus 4, so just x minus 2 squared. Our turning point would be at 2, 0. So it would be at this point here. And we've got our parabola like that. This is our graph of y is equal to x squared minus 4x plus 4. Now say we were tasked to solve the equation x squared minus 4x plus 4 is equal to 0. And so this equation would arise from having y equals x squared minus 4x plus 4 and y is equal to 0. Okay, because it means they would have had these two equations, then equated the x squared minus 4x plus 4 to the 0. Okay, and so this y equals 0 is our x-axis, and this y is equal to x squared minus 4x plus 4 is our curve. So if we're solving this equation, we're looking for the points of intersection between our curve and our x-axis. And as you can see here, we only have one point of intersection, which is what we call our one real root, or sometimes referred to as a repeated root. So for example, if we were to factorize our equation, we've got x squared minus 4x plus 4 is equal to 0. If you factorize this, you find that you get x minus 2 times x minus 2 is equal to 0. And so both brackets give us x equals 2, x equals 2. And this is why they call it a repeated root, because you can see here it's being repeated. And we can even use our discriminant just to confirm that in fact our discriminant is equal to 0 since we have one real root. So our a here is the coefficient of x squared, which is 1, b is the coefficient of x, which is negative 4, and c is the constant, which is 4. So b squared, that's negative 4 squared, minus 4a, which is 1, c, which is 4. You're going to get negative 4 squared, which is 16, minus 4 times 4, which is 16, and this yields a 0. So our discriminant is in fact equal to 0, hence why we get one real root or a repeated root. So now let's put all of this into practice and actually solve some past paper questions. So let's start with this one. Find the set of values of k for which the equation 8x squared plus kx plus 2 is equal to 0 has no real roots. Okay, so we've been told that our equation has no real roots. So what does that mean in terms of the discriminant? It means b squared minus 4ac is less than 0. Okay, because we say this is the condition in which we have no real roots. No real roots. And we've been given the equation 8x squared plus kx plus 2 is equal to 0. So in this case, we simply identify what a is, what b is, and what c is, and we substitute into our discriminant. So a is the coefficient of x squared, so that's 8. B is the coefficient of x, so that's k. C is the constant, so that's 2. And now let's substitute into our discriminant. So that becomes k squared minus 4 times 8 times our c is 2, and this is less than 0. So you get k squared minus, that's 4 times 8, which is 32, times 2, that's 64, and this is less than 0. So now we end up with a quadratic inequality, and we're going to solve this how we typically solve quadratic inequalities. So for a quadratic inequality, you're going to first equate this expression, the quadratic, to 0 and find its roots. So k squared minus 64 equals 0. This actually happens to be a difference of 2 squares because we can write 64 as 8 squared. Alright, and so this allows us to then factorize this as k minus 8, k plus 8 is equal to 0. If you're not familiar with a difference of 2 squares, this is when you have a squared minus b squared is equal to 0. You can factorize this to be a minus b times a plus b is equal to 0. That's what we did here. We've got k squared minus 8 squared, so that's k minus 8 times k plus 8. Alright, so our solutions here are k is, we get plus or minus 8. And so let's sketch our function, our parabola. This is, in fact, since we're dealing with k, we'll call this the k-axis. And we've got our curve, we've got negative 8 and positive 8. We're looking for the less than region, so we want the region below the k-axis, so that's going to be this region over here. And so our solution here becomes where k is between -8 and 8. So that would be our final answer. And what this means is that we are saying that our equation here has no real roots when k is between -8 and 8. And notice that in the question they have said set of values of k. So anytime they tell you to find the set of values, they want an inequality. Alright, so now let's look at a slightly more complicated example. We're given that a curve has equation y equals x squared plus 2cx plus 4, and a straight line has equation y equals 4x plus c, where c is a constant. Find the set of values of c for which the curve and the line intersect at two distinct points. So two distinct points tells us that our discriminant b squared minus 4ac is greater than 0. This is the scenario in which we get two real roots or two distinct roots. Okay, so we've been told that we've got a curve y equals x squared plus 2cx plus 4, and we've got a line y equals 4x plus c, and they want us to find the set of values of c. Again, they've said set of values, so that means we're probably looking for an inequality where the curve and the line intersect. So since we're looking for a point of intersection, we're going to have to solve simultaneously. So what that means is that we start by equating this to this, so the expression for the curve to the expression for the line. That becomes x squared plus 2cx plus 4 is equal to 4x plus c. And our goal here is to put everything on one side and reduce this to a 3-term quadratic. From that point, we can then use the discriminant. Okay, so this becomes x squared plus 2cx. I'll bring the 4x to the left, so it becomes negative 4x plus 4, and then let's bring the c to the left, it becomes minus c, and this is equal to 0. So we've got x squared. Now I'm just going to factor out the x here so we can clearly see what b is. So this becomes 2c minus 4x plus 4 minus c equals 0. And so from here we can determine what a is, what b is, and what c is. So in this case we're going to get that a is 1, and then b, that's the coefficient of x, so that's going to be 2c minus 4, and then what would typically be c, I'm just going to write this as d just so that we don't get confused with the letters, but d is representing this c over here, so that's 4 minus c, because that's the term independent of x. And now we can substitute into our discriminant. So we've got b squared, that would be 2c minus 4 squared minus 4 times a, which is 1, times c, which we're saying we're going to represent as d, just so that we don't confuse the letters, 4 minus c, and this is all greater than 0. So let's expand our quadratic here. So let's start by squaring our 2c here. So square the 2 and then square the c. 2 squared is 4. Then we've got c squared. Then multiply 2 by 2c by negative 4. So 2 times 2c, that's 4c, times negative 4, that's negative 16c. And then square the negative 4, that's positive 16. And now let's multiply this as well. So that's going to be negative 4 times 4, which is negative 16, and negative 4 times negative c, which is a positive 4c, and this is all greater than 0. Okay, so let's simplify like terms if we have any. So we've got 4c squared, which is here, and then we've got negative 16c plus 4c, so that's going to be negative 12c, and then 16 minus 16 will cancel out, and this is greater than 0. So again, we ended up with a quadratic inequality. So let's start by solving and finding our roots. So 4c squared minus 12c is equal to 0, and this is a 2-term quadratic, so we can factor out a 4c here, and we end up with c minus, that's 12c divided by 4c, that's 3. So c minus 3, and this is equal to 0. So you get that c is either 0 or c is equal to 3. And so from here we can sketch a diagram. Since we're dealing with c, this will be the c-axis, and we've got our parabola. Our first intercept is at 0 and our second intercept is at 3. We're looking for that region above our axis, so that's going to be these two regions, these two separate regions. Alright, so you get that either c is less than 0 or c is greater than 3. Okay, these are the regions in which our curve and line intersect at two distinct points. Alright, and again, like I said, they said set of values, and so your final answer was an inequality. Alright, let's look at one last example together. So we've been given that the line with the equation y equals kx minus k, where k is a positive constant, is a tangent to the curve with the equation y is equal to negative 1 over 2x. Find in either order the value of k and the coordinates of the point where the tangent meets the curve. Alright, so here the keyword is tangent. The line is tangent to the curve. So say you've got a quadratic curve and you've got a line that is tangent to that curve. What that means is that they intersect at only one point. Okay? And so if they intersect at only one point, it means they only have one real root. So what does that mean for our discriminant? It means that our discriminant b squared minus 4ac is equal to 0, because this is the scenario in which we have one real root or in which we have a repeated root. So anytime you hear the word tangent, think of the discriminant being equal to 0, because if we have a line tangent to the curve, they only intersect once, meaning we only have one real root or a repeated root. Okay, so we've been given the equation of the line to be y equals kx minus k, and the equation of our curve is y is equal to negative 1 over 2x. So since we're looking for the coordinates of the point of intersection, we start off by solving simultaneously. So equate kx minus k to negative 1 over 2x. So kx minus k is equal to negative 1 over 2x, and let's multiply both sides by 2x to get rid of our denominator here. That becomes 2x times kx minus k is equal to negative 1. So 2x times kx gives us 2kx squared, and then 2x times negative k, that gives us negative 2kx, and this is all equal to negative 1. Let's move the negative 1 to the left hand side. So that becomes 2kx squared minus 2kx plus 1 is equal to 0. Now that we have reduced this to a 3-term quadratic, we can now apply our discriminant, b squared minus 4ac, and in this instance, since we're looking at a tangent, it means our discriminant is equal to 0. Alright, so a is going to be 2k, b is equal to negative 2k, and then c is our constant, which is 1. So let's substitute into the discriminant. That's negative 2k squared minus 4 times a, which is 2k, times c, which is 1, and this is equal to 0. So let's expand this. We've got negative 2k squared, so square the negative 2, you get 4. Square the k, you get k squared. Then we've got minus 4 times 2k minus 8k, and this is equal to 0. Alright, so we've got a 2-term quadratic, and here we can factor out a 4k. So in the brackets we've got k minus 2 is equal to 0. So you get that either k is 0 or k is equal to 2. So in the question we're told to find the value of k, right? So it means there's only one value of k. But they told us that k is a positive constant. So it means that we disregard the 0. We take k is equal to 2. That's going to be our value for k. And we also have to find the coordinates of the point where the tangent meets the curve. So we have to find the point of intersection. Now remember, to find the point of intersection, you have to solve simultaneously. So that's what we were already doing when we ended up with this 3-term quadratic. Because remember, we started with our 2 equations, we equated them together and then simplified to this 3-term quadratic over here. But we couldn't solve it because we had this k. We didn't know what k was. Now that we have k, we can substitute our value for k into this equation and solve that equation, and we get the coordinates of our point of intersection, the coordinate of the point where the line is tangent to the curve. So we said k is equal to 2, so that becomes 2 times 2x squared minus 2 times 2x plus 1 is equal to 0. So 2 times 2, that's going to be 4x squared. Then minus 2 times 2, that's going to be minus 4x plus 1 is equal to 0. So we've got a 3-term quadratic that we can factorize by side. We can do 2x is equal to 0, 1 to get negative 4x, so negative 1. Alright, so it means that, as you can see, our brackets are the same, so they would give us a repeated root, one real root, otherwise known as a repeated root. Okay, so our repeated root here will be 2x minus 1 is 0, 2x is equal to 1, so x is equal to 1 over 2. That would be the x coordinate. But they want the coordinates of the point, so we also need to find the y coordinate. So we can use this equation that we have over here and say that y is equal to negative 1 over 2 times 1 over 2. Y is equal to, that's going to be the 2 and the half here will cancel out, so we end up with negative 1. So we get that, therefore, the coordinates of the point where the line is tangent to the curve are 1 over 2, negative 1, and our value for k is equal to 2, and that's our final answer. Alright, so that's it for the discriminant. Make sure to go through the quiz, and I will see you in the next video.